This is the second assignment that we are going to solve
We
today.
are going to discuss the Numpy linear algebra module. So this module actually, you know, has the syntax like NumPy dot, we have a dot here, lin, L-I-N-A-L-G dot method name, and we have the parameters for the same method. So lin over here stands for linear and ALG stands over here for algebra, right? As Is that obvious? All right. So we have a lot of methods. So we are actually going to discuss a solve method. NumPy. We can import NumPy as NP, and we can we have this function np dot len and solve click on the B. It just solves for linear equations. So solves the values of values for a system of linear equations. All right. So the second function which we have over here is for determinants. So solve determinants. Well, yeah. All right. So this actually calculates the determinant of a matrix. It's basically about, let me just read it out to you guys. Sorry about that. The assignment was on a NumPy numerical Python, and we were supposed to explore the NumPy documentation website. We were supposed to demonstrate 5 NumPy arrays in the assignment, and then we were supposed to share our work. So basically what we were supposed to do were all these three things, and we are going to learn about 5 NumPy arrays. I have basically dealt um, with a lot of NumPy array operations from linear algebra. There are hundreds of NumPy routines which you can learn and implement, but I have delved into linear algebra, so let's just get the hang of NumPy for now. Yeah, let me just open my Python notebook and close this tab. Let me close these things. This is about right. Okay, header top. Okay. 5 interesting NumPy modules. Okay, I was supposed to write the documentation for this assignment, but I ran short of time because have a little work right now. So let's just really dive into it. No bullshit. Okay, let's just, import. Let's just do the basic things that you're supposed to do. Okay, okay. Okay, so as we are starting NumPy, we can import this library as NP. So the thing this command does, it just imports the NumPy library, and it just replaces the NumPy. We don't have to write the whole NumPy thing every time we use a module of this library. So we just import it as NumPy. We use the namespace NumPy. Okay, the first function we are going to use is np dot linear algebra. LINALG stands for linear algebra dot solve. What does this do actually? Uh, in this function, we can solve a system of linear equations. Like you all know, a linear equation is of the form ax equals b in matrix form. The equations we are supposed to study in our, you know, high school. You can see this with two variables. It's 3x plus y equals 9. This is a linear equation, and these two equations forms a system of linear equation. And if we are supposed to solve this, we can write this in matrix form, where A is the coefficient matrix and B is the constant matrix. Everything on the left side of the equation is the variables with the constants or coefficients of the variables. So here we have 3, and here we have invisible 1, and here we have 9, which is the constant. So 3 and 1 are the coefficients of x and y, and in the second equation we have 1 and 2 as the coefficients. So what can we have, like the A matrix? We can write it in Python as a list of, of with a 2D list of 3 and 1, 2 and 1 pairs. Okay, and where B is a single dimension array, or you may call it list, which has 9, a constant 9 and 8. So what this function actually does, it solves for us. Okay, so we have a working example over here, a system of two linear equation with two variables. Mind you, we have two variables. So the first, you know thing the first parameter we have is A over here. So the A is always the coefficient matrix. We have coefficients 3 and 1 and 1 and 2. So we write it as square bracket open, square bracket open, 3 comma 1 comma 1 comma 2. All right, and then we have the constant matrix 9 comma 8. So when we apply this, np.linearalgebra.solve a comma b, so we are supposed to get, okay, we have a name error, we did not import the, all right, let's just import the numpy library. All right, so the first we imported the numpy library. That error was just because we had np error and we did not import the numpy library. Okay, so when we solve here, we get the solution x equals 2 and y equals 3. So how did we get that? We can, solve it using substitution method. We have a pretty basic explanation over here. Since 3x plus y equals 9, we can, subjectify y and put 3x over there. We get y equals 9 minus 3x. And then in the second equation, we have plus 2y equals 8. When we substitute the value of y over there, we can substitute, where did it go? So we can substitute in place of 2y, we can 2 bracket 9 minus 3x, which we had from the first equation, equals 8. Now we have 2 plus 2 times 9, 18 minus 6x equals 8. And then when we solve it, we get minus 5x plus 18 equals 8, x equals 18 minus 8 by 5, which is 10 by 5 equals 2, and which we have x equals 2. So x over here is the solution matrix or the variable matrix over here, which we get on solving. Whatever the value over here we get the x matrix. All right. So let me just, yeah. So here we got, and then we substitute x in place of y, in place of the other equation, in the equation of y. 9 minus 3x equals 9 minus 3 times 2, which is 9 minus 6 is 3. So it matches our output. Okay. So in the second example, what we can do over here, we can take three variables, a system of linear equations, two linear equations with three variables. All right. Let's just do it. So this example will have something like 6x plus 2y minus 5z equals 13, 3x plus 3y minus 2z equals 13, 7x plus 5y minus 3z equals 26. We have this system of linear equation with three variables. All right, so when we are supposed to solve that, we have a list having
columns as follows. We have these elements, and then we have B over here, which is the constant matrix. When we plug these lists into the function, we get the values 2, 3, and 1. X equals 2, 3, y equals 3, and 1, z equals 1. Okay, the resulting array or the solution of the matrix has x equals x, y, z. This is the solution matrix where x equals 2, y equals 3, and z equals 1. We can, check it by using substitution. So one important thing which we need to care about is if we have a linear equation with three variables, in order to get the solution of that linear equation, we need to have three equations as well. You know, if there are three variables, we need three equations also to get every possible, every solution for every variable. All right, so we have just two equations over here, and we have an error. So this actually technically won't should not be here. It's just so the last dimension over here is not available. So we have x plus 2y equal plus 6z equals 5, and 3x plus 4y plus 7z equals 6. But then we don't have the third equation, so we can't really find all the values of x, y, and z. So we have this error over here. The last two dimension of the array. So it's a linear algebra error. You can read more about it. So this actually throwed a linear algebra error because the matrix A is supposed to be a square matrix also. Yeah, yeah, square matrix. If there are supposed to be the number of variables, which is the number of columns, and the number of equations, which is to be the number of rows, they are supposed to be equal, then the matrix will be a square matrix. And the matrix A is always supposed to be a square matrix, which in this our case, which throwed an error, is not a square matrix, it's a rectangular matrix. Okay, so it must have equal number of rows and equal number of columns. A quick fix to the problem is to assume that the not given terms is 0. So let's just fix this. Okay, so we can assume here to be 0 this solution, and we can have all the values over here as 0, 0, 0, 0, 0, 0. Let me do the spacing, right? Okay, so we also have, it should also be a singular matrix, that at least one element on the matrix should have some constant value. Okay, let's just assume that we have one over here. Now we can solve it. You know, we have pretty complicated values in scientific notation, but you don't have to care about that. Let's just move ahead. Okay, let me just undo my thing so that it just remains error. Yeah, let's just let the error be, because I have to supposed to you're supposed to show the error, and you have to give the explanation over here. So the second function is np dot linear algebra dot determinant of a matrix A. So what is the second function over here? We are supposed to have, okay, A. All right, now we have A comma B. We have two parameters over here. There's two lists which we can give. Okay, so the second function is finding a determinant for a matrix, for a square matrix specifically. So what is a determinant? Determinant of a matrix A or an array is is defined as the difference in products of diagonal elements. If you see it like this, huh? So this multiplied by this minus this multiplied by this will be the determinant value of A. So we can use a function to calculate. So 1 times 4 is 4, 3 times 2 is 6, 4 minus 6 is minus 2, which we have over here. Okay, we use np dot linear algebra dot determinant of A, we get the answer. All right, so let's just compute it, although I have already completed it. So what is the explanation over here? The determinant of the matrix A
is supposed to be the, let me just not say it all while I'm typing. Supposed to be the, let me just search it for you on Wikipedia or something. Let me just add a link for the, so you can have some. Okay, I have the dark font medium over here. Yeah, let me just add it for extra information. All right. So the, okay, let me just all right. So now we are done with matrix, 2 by 2 matrix. We calculated the determinant for it. Now we are going to see for a matrix having 3 by 3 elements, that is 9 elements. So the first matrix which we have here for a 3 cross 3 matrix. A. All right. So the first matrix has the components 1, 2, and 3. The second row has 4, 5, 6, and the third row has 7, 8, 9. So when we calculate the determinant of A, we get 0. So how are we supposed to calculate a determinant for a 3 by 3 matrix? All right. So how are we supposed to do that? Let me, if you want me to go down to the nitty-gritty of it, I'll just explain it to you real fast. So for a matrix, if you want to calculate the determinant of a matrix, we are supposed to take the first element and then we are supposed to multiply it by the cofactor of the that particular element. So the cofactor will be, we are supposed to hide this whole row, this whole row over here, this whole row, and this whole column. All right. And then we are supposed to take the determinant of this 2 cross 2 matrix, which will be 5 times 9 minus 8 times 6, which will be something. And then we are going to, we have plus, minus, and plus over here. So we have minus 2 times 4 times 9. We hide this and this. And then we take the cofactor. Here it is 4 times 9 minus 7 times 6. And then we add up 3 times the cofactor of this element, this A of ij. This is the first and third. No? This is A of 1 comma 3. All right, so we have 4 times 8 minus 7 times 5. When we do all this calculation, we just get 0. Okay, so uh, so let me just make a, just to illustrate when it breaks, we can take a non-square matrix. We cannot find the determinant for a matrix which is not a square matrix. We need to have 2 cross 2, 3 cross 3, 4 cross 4 elements in that matrix. So A over here is a 1D matrix which has 2 elements, which is obviously not a square matrix, so it should throw an error, which you can already see. Sorry for the spoilers. Yeah, so we have this linear algebra error. Okay, what is the error? One-dimensional array is an array must be at least two-dimensional. Okay, so this is actually not written. Let me just dd it, dd delete that one, because all the explanation over here is already given. I mean, you not write the explanation. Okay, so over here we have the third function, which just takes the inverse of a matrix All right. So what is an inverse? Inverse actually for a matrix which is written as A, you can say it to the power minus 1, but it does not mean that we raise it to the power minus 1. It's just the inverse. We just say it. Mathematically, A times A inverse should be equal to an identity matrix. When we multiply A with the inverse of that same matrix A, we should get an identity matrix. So we should just add some explanation. Inverse of the of the let's just call it A dash or A prime, whatever, just for the sake of notation purposes. Um, hmm, inverse inverse equal to identity matrix. No, an identity matrix should be something like 1 0 1 yeah, something like this. A 2D identity matrix is something like this. That is, yeah. Oh, all right. Yeah. So to calculate the inverse of a matrix, so in order to, just to add some more information, I can, add the link of the Wikipedia over here, and we can see something good over there as well. It's just invertible, no, not invertible matrix, inverse of a matrix. Yeah, let's just add this. Maths is fun. All right. So what is this over here? And that's a pretty long post. All right. Let's just not get deviated from this. I'll do the corrections later after in the video. All right. So the first example says over here we have a 2 cross 2 matrix with elements 1, 2, 3, 4. All right. So we just do the np dot lin alg dot inverse a. So we get so this is actually the syntax of the numpy function, all right, in Python. Okay, so we get the inverse over here as minus 2 1 1.5 minus 0.5. This is the inverse of the matrix. All right, yeah, let's just get over it. So we have a working 3 cross 3 matrix. So we have a usual 3 cross 3 matrix with the elements as follows, and when we do this, operation, we get this pretty complicated inverted matrix A inverse. Okay, explanation is pretty basic. In order to just break the function so that we get to know an important point about the function, that uh, fun a matrix to be an invertible matrix, it should be a square matrix. All right, supposed to be a square matrix. Okay, this is the sorry about this part. The last two dimensions should be square. All right, simple. So we have a rank of a matrix. Okay, what's the rank of a matrix? How many elements does it have on the diagonal element over here? Yeah, diagonal element, or the number of zeros it has
Now we can just read it upon the internet. Mm, yeah. We have the rank for this 3 cross 3 matrix. Cross 3 matrix in rank. All right. So we have the rank 1. Okay. So we have an identity matrix with 4 by 4 matrix. It is a full rank matrix because it has every row has some element in it. It does not have any, every row has non-zero rows basically. So it is a full rank matrix. Yeah, 4 as the rank. So what is it's a null matrix. All right, so we have a null matrix. It just gives a 0 because it does not have any element, so its rank is pretty obvious.